Alright, now we're going to look at lesson 61, question number F. It says push a car 42 feet up a 30% grade, applying 47.3 pounds of horizontal force. How much work is done? Okay, what on earth does that mean? So if you can imagine, here we are, we've got a 30% grade, and we've got this car, it's got to go up 42 feet. Let's say 42 feet. But the people who are pushing it are standing here. You know, we're human beings. We like to kind of be oriented with gravity. So they're pushing. Oh, isn't that a beautiful stick figure? They're pushing this way. They're applying the force this way. And that's 47.3 pounds of force. So that is the force. Which we think of as the magnitude. But that force is going to have two effects. It's going to have an effect of pushing the car up the hill, but it's also going to be counteracting another force, and this one's a little bit harder to think about. I'm going to say it's going to counteract a force that's perpendicular to the hill there. So maybe we could visualize this as this is the force vector. There, I'll make it nice and big there. And then they're pushing the car into the hill. And the result is that it's going up the hill, certainly, but some of the pushing, because they're pushing kind of toward the hill, not up the hill. They're not getting, they're not crouching down and, putting the force into the bumper of the car there. They're kind of standing up and pushing downward a little bit at an angle. Some of that force is going into the hill. It's kind of working against gravity, I suppose. So there's two pieces to this force, and we want to know about the piece that's going up the hill, and then we're going to multiply that by the distance that's traveled. So the 47.3 pounds times the 40, or however many pounds of force is actually getting applied up the hill, and how much work. Okay, so or what the distance is times the distance. So we're going to call these, we'll call this F1, and I already did. Let's say, well, that's okay. And we'll call this F2. There's a second. Maybe we'll call it X and Y. Okay, now, one of the cool things that we can do here is we can turn this. Whoops. Let's do this. I think this will be kind of nifty. We're going to take this and we're going to turn it so that the up the hill is going to be our horizontal, and so I'm just kind of tilted my head sideways, so the up the hill is now the X direction, and then there's this force that's kind of the amount that's getting pushed into the hill. And we can see that we have here an angle 30 degrees, and the opposite side is the y force. That would be the opposite over the hypotenuse would be the sine. So the sine of 30 equals the Fy, absolute value of Fy, over the hypotenuse, 47.3. And I think this is in our notes, so Fy is equal to the the initial force, the hypotenuse force, 47.3 times the sine of 30 degrees. Okay, so that's one, and we don't care about that one because that's not the question. The question was, what's the other force? So the what I'm calling Fx, the force in the x direction, is equal to the same, the original force, 47.3, that blue vector, times the cosine of 30 degrees. And again, we can verify this because there's 30 degrees, this is a right triangle here, and if we want to visualize this as a right triangle, the force in the x direction is the adjacent side, the force in the y direction, going into the hill, or perpendicular to the hill, is the opposite side, and the initial force kind of in the direction that they were pushing, which is horizontal with the ground in reality, remember I tilted it, is the hypotenuse, and so that's the cosine of the adjacent, cosine is the adjacent side over the hypotenuse. Okay, so we can calculate that out. We'll get our calculator here and get that done. Okay, so on my calculator, 47.3 times the cosine of 30 is approximately 0.96. Let's call that 41.0. Alright, so even though they're pushing with 47.3 pounds of force, it's only about 41 pounds of force going into pushing the car up the hill. Because they're just going at a bad angle, and we can go back and change the orientation if we want to, just to kind of visualize this. They're going at a bad angle, and so probably ruined my picture, but there you go. They're pushing straight when they should be really pushing at an angle upward. Okay, so there's the force that they're pushing with. It's 41 pounds. And then we just multiply that, 41 pounds, oops, of force times the distance that they're traveling, which is 42 feet. And 41 times 42 is 1,722 units of work. And I don't know if that's newtons or what, but that's the idea to get that one. Alright, thank you for watching.